Let's see number 5. Now this one's on summations. Now, most of the time in an A-level exam, you're probably going to get a standard summation where it's a geometric series or an arithmetic series. But when it's written in this form, which is a little bit non-standard, like in the first one and the second one, it's often going to be helpful to write out the terms. So what I mean by this, we're going to write out when r equals 4. So we're going to have 20 times a half to the power of 4 plus, then when we have r equals 5, so 20 times a half to the power of 5. And well, what you're seeing in each time, we're multiplying by a half. So it's like we've got a geometric series where this is a, our first term, and r is equal to a half. Bit confusing, they've used r in this term, but when I'm talking about r here, I mean the common ratio of a geometric series. So what we know is this sum up here, which I'm just going to call s, we know that s is equal to a over 1 minus r. This is in your form booklet. So we get the a, which is 20 times a half to the power of 4, divided by 1 minus a half. Well, the bottom is a half, so we're actually going to get 20 times a half cubed. And this comes out to be, it's going to be 4 over 8, which is a half, so we're going to get 5 over 2. Well, what I've done there to calculate that, I've done that in my head. I've grouped up the powers of 2 in the 20 and cancelled them with the half. But yeah, you can put that in your calculator. Part 2, show that this is equal to 2. So again, we're going to have to consider the sum. So what I'm going to do for part 2, I'm going to say left hand side is equal to. Now, again, I'm going to write out my terms. So I've got log 5 of, well, this is going to be 3 over 2 plus log 5, and then we're going to have 4 over 3 dot 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 dot, and eventually when it gets to the 48, we're going to have plus log 5. Putting 48 in, we get 50 and 49 on the bottom. Now there's lots of ways of doing it. You sort of confront yourself, you go, well, it's not an arithmetic series because we're not adding each term. Each term is not, there's not the same addition, there's not a common difference here. And it can't be geometric because there's not a common ratio here as well. And you can check that with your calculator. Divide this term and this term, and then the term after it and this term, and you'll see that you get a non-standard common ratio. So you've got to think of something different. So when you're in this point and you're kind of losing ideas, your ideas should go, well, what are we dealing with? We're dealing with a logarithm. What do we know about logarithm? What properties do we have? Well, we know when we add two logarithms, we times the inside. We also know that with a fraction inside, it's like I can split it up. So there's two ways you can do it. So using the first identity, we can add the logarithms. It's like I'm multiplying the inside. But that means I can do it to the next one, and to the next one, and to the next one. So what we're going to get is log 5 of 3 times 4 times 5 all the way up to 50. And on the bottom we're going to have 2 times 3 times 4 blah 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 all the way up to 49. So what's going to happen? Well, these are all going to cancel with this, and well, we're going to be left with log 5 or 50 over 2, which is in fact log 5 of 25, and well, that's just 2. So that's one way of doing it. That's using that logarithm rule where we can add stuff. Now what about the subtraction one? This one I think is more logical than this. The subtraction one, we have log 5 of 3 minus log 5 of 2. And if you're a further math student, you've probably seen this technique before. It's called telescoping. The next one is log 5 of 4 minus log 5 of 3 dot 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 plus log 5 of 50 minus log 5 of 49. And well, what cancels? Well, this first bracket, they don't cancel each other, but from the next bracket, this cancels with this. So the previous bracket, the first thing's going to cancel. The next bracket, the second thing's going to cancel. So this is going to disappear. This is going to disappear. Everything else in between is going to disappear. And we're going to be left with log 5 of 50 minus log 5 of 2. And well, again, that's just going to be equal to 2. Because we can use the subtraction of logs, it's like we divide the insides. So in this question, although it's framed like it wants you to do something with the summations formulas, it's not necessarily going to be that way. This is a very difficult question. This is almost sort of verging on the further math side. But the idea is simple. We're dealing with logs, try use log rules. So for this one, as soon as I saw it, when I see this a sin x plus b cos x, this should make you think of the r cos form. So this is identical to r cos x minus alpha or plus alpha. I'm going to keep it as minus alpha simply because it's going to be nicer. Potentially it'll be nicer. Now also, what I can see when looking at the graph down here, this kind of looks like cos. Cos starts like this, goes down, goes back up. It starts at the higher point. So that's why I've chose cos, and I've chose cos to be moved to the right. Minus alpha. Alpha, remember, inside is opposite for translations. So how would this help us? Well, our whole goal is to find a and b. If I know what r and alpha is, then I'm done, essentially, because I can then expand this and I found a and I found b. Easy. So why is this useful? Well, if you think back to this r cos form, and I've got a video on this, so you can check that out. We saw in this r cos form that r is the maximum. So when we're told that the maximum value of y is 4, we can just straight away go that r is 4. Which is super amazing. Now, a lot of you may straight go into try differentiate, because maximum is a trigger word for finding stationary points and then using the stationary point, because we know maximums occur at stationary points, so we use the stationary point to test if it's a maximum or not. However, you've got to look at the other ways that we can find maximums, and the main way is by algebraic manipulation. So we saw completing a square back at GCSE and the start of A-level. Then you see this r cos form and other sort of familiar functions that you might know of. So e to x is strictly bigger than 0, so you can use that to find its lowest points and whatnot. So certain tricks like this. And what you'd find by differentiation is you'd find this would be a very difficult question to tackle. So anyway, we've got that r is 4, so we have that y equals 4 cos x minus alpha. Now my next task is to find alpha. I need some information. What other stuff we told? So a and b are constants, pretty standard. The maximum value of y is 4. We've already used that fact. The curve passes through the point. This is a piece of information. Now you should also look for stuff on the graph. They haven't labelled anything, but you should look for things like crosses through the origin or maximum points that are labelled on. You should look for this stuff because it potentially will be useful, potentially will be needed. So we're told it goes for a certain point, so let's sub this point in. So when y is 2 root 3, x is pi over 3. Dividing by 4, so then we can take inverse cos on both sides. We get root 3 over 2 equals cos of pi on 3 minus alpha. Okay, nice, not so bad so far. Next, we can do inverse cos on both sides. So we can do inverse cos. Well, inverse cos of root 3 over 2, that's 30 degrees, or in other words, pi on 6. So we get pi on 6 equals pi on 3 minus alpha, which gives us alpha equals pi on 3 minus pi on 6. And well, that's just going to be pi on 6. So all in all, we have that y equals 4 cos x minus pi on 6, which is equal to 4 cos x cos pi on 6 plus 4 sin x sin pi on 6. And well, that's going to give us 2 root 3 cos x plus 2 sin x. And we're done. So a equals 2, b equals 2 root 3. So for this one, we've got a differential equation. I haven't put this higher up because differential equations generally are pretty repetitive / algorithmic questions. If you do 10 or so, maybe less differential equation questions, you'll probably be able to attempt most differential equations. This one is still in the list because of the sort of the second part. So our first idea is we need to actually show that C, we need to find what C is. And then we need to show this. That's going to be potentially the tricky part. So we're told that a curve C passes through the point with coordinates 1, 6. This is our information that's going to help us find our unknown. So with the differential equation, we're going to integrate at some point. When we integrate, we have a plus C, plus little c, or any unknown letter, D, F, whatever. Confusingly, they've used the curve C. So curve C passes through this point. This is going to be information we need to use later. The gradient of C is given by this. This is our differential equation. Show that C intersects the coordinate axes at exactly one point and state the coordinates at this point. So basically what we need to do is we need to find y. And then we're trying to show that it intersects the coordinates axes at exactly one point. So x equals 0, there's only going to be one corresponding y value. Or y equals 0, there's only going to be one corresponding x value. But there's not going to be, both of these won't happen. There will only be one of these. So let's have a look at this. So first of all, it's a separable differential equation. So I need to bring everything that's on the top of the derivative to the side of the derivative. So dy, so I need to bring all the y's to the left side by multiplication. So I'm going to multiply by 1 over y squared. Or in other words, divide by y squared. That gives me this. Next, I'm going to integrate both sides with respect to x. So we get 1 over y squared, dy, dx, dx equals the integral of 1 over 6 x squared dx. Now, the dy integral on the left, and this is the integral of y to the minus 2 dy. And on the right, well, this one's quite easy. We increase the power of x, and we divide by the new power. So we're now dividing by 18, because a sixth divided by 3. And this is where we need our plus our little c here. Doing the same on the right side, we get y to the minus 1, divided by minus 1, equals x cubed over 18 plus c. Now next, we need to make use of our information, the 1, 6. That's going to tell us c. So we know that this curve is going to pass through the point 1, 6. So we have 6 to the power of minus 1, but we've got a negative, is equal to 1 cubed over 18 plus c. Or in other words, we get an 18th, subtract a 6th equals c. So c is going to be 4 over 18, or negative 4 over 18, where and that simplifies to be minus 2 over 9. So we get y to the minus 1 is equal to, bringing a negative over, minus x cubed over 18 minus 2 over 9. Plus 2 over 9 now, because we've multiplied by the minus 1. Now next, clearly, we get from this that y cannot be 0. So we rule out the first case. Y cannot be 0. And we should probably state our reason for this. Why can y not be 0? And that's because we can't divide by 0. So that's going to get us a reason mark. Next, we need to check the case when x equals 0 and show there's only one y value. So, what about when x equals 0? Well, here we get y to the minus 1 equals, well, this here is going to be 0, plus 2 over 9. And that's going to give us y to the minus 1 equals 2 over 9, taking in the negative power on both sides to give us just positive y to the 1. That's going to give us 9 over 2. Because remember, if I take a negative power on both sides, I swap the power, swap the fraction, like this. So we get y equals 2. So, only one intersection at 0, 9 over 2. So not too bad. This is why it's not higher up on the list. The main thing is understanding what this means, what the one intersection with the coordinate axes, not just the x-axis, which a lot of people would go into the trap of doing, but the coordinate axes, so the y-axis or the x-axis. So this particular example is quite hard because it's a vectors question, and you would have seen there's a lot of GCSE, but it doesn't particularly come up very much at A-level, and there's not many exam questions for you to practice on. Now, this one is pretty much going to use the same rules you would have seen at GCSE, except in a lot more of a tricky scenario. So let's have a look. So first of all, most important thing, we need to draw a diagram. So figure 7 shows us a sketch of triangle OAB. So let's draw OAB on our own. And I recommend redrawing their diagrams just so it's bigger and something you can annotate quite easily. Next, the point C is such that O to C is equal to twice the size of O to A. So O to A goes along this line. O to C is 2 of this line. So C is going to be up here. And I'm just going to move up to make sure it's on the board. And then we have the midpoint of AB is M. So if I mark that on, we have M. And we're told that the straight line through C and M cuts OB at the point N. So a straight line through C and M cuts OB at the point N. So it's going to go through and it's going to cut here at a point that we're going to call N. Given OA is A and O to B is B, find C to M. So O to A is A, O to B is B. This means this is also A because we're told O to C is 2A, which means this must be A. Now we're told to find C to M. So our first logical step for finding C to M, we're going to find C to A. Well, that's actually minus A, so I'm going to actually write that in on the next line. Then what we need either A to M or we need to go round. So we need to go round like this, or we need to go through like this. Now, unfortunately, we don't know any of these, so we don't actually know. We know this way and this way, but unfortunately, we don't know this. But what we do know is some facts about M. M is the midpoint of AB, which means if this here is R, and this here would then also be R, so we'd have A to B equals 2R, and we'd have A to M is equal to R. So in other words, if we can find A to B, we can find A to M. Now a to b, we can go round like this. So I'm just going to add this on, by the way. I'm going to add a to m. And we know that c to a was negative a. And a to m, well, it's going to be a half of a to b. But a to b is just going round from a to o to b. So negative a plus b. And overall, we're going to get minus 3 over 2a plus a half b. And that's our c to m. Okay, nice. Now, a bit of exam technique. Whenever you get a question that features multiple parts, you should try and look for how different parts are going to link to each other, especially when these are each 2 marks, but it feels like quite a lot of work that we're doing. So you should be looking for ways that we can use part A and part B. So anyway, part B, show O to n is equal to this. Now this looks like something quite hard to get to, but whenever there's like a lambda, we're going to basically try to use the fact that 2 lines are parallel. We're going to try exploit that fact. So anyway, so O to n, we're talking about, I'm going to do some rubbing out here, just to make the diagram a little bit easier to read. If we're talking about O to m, we're talking about this line here. And, well, how can we find this way? In what ways can we do this? Well, we could go up to C, and then down to M, down to B, and well, and then to N, but that's quite tricky. Or we could go up to C and use the fact that C to N is sort of like an extension. So it's kind of like lambda multiplied by Cn. And I'm actually not going to use lambda because I don't know if this constant is going to be incorrect. So I'm going to actually use mu. So I'm going to say that mu times Cm is equal to C to n. And we have the O to n, which I'll write down in the bottom left here, is equal to O to C plus C to n. Now O to C is simply 2a. Plus, and then we're having C to n. Well, that's mu times C to m. Now, the reason I've chosen to use C to m and I've chosen to go up to C is that little tip that I just said. We want to try and involve part A. So that's how we've involved part A. So this is mu multiplied by minus 3 over 2a plus a half b. And well, expanding this all out, we do in fact get part B. So we get that if we factor out the a's, we have 2, a singular 2, minus 3 over 2 mu, that's our a's, and then we have a half mu b. I'm not going to bother writing this out in terms of lambda. I chose mu so we don't have to make a change of variables later on. But yeah, it worked out fine anyway. This final part's really tricky, and most students in the actual exam were not able to do this. This is a very tricky part. So a lot of people try to find different ways of finding O to n, or tried to find n to b, and then showed that it was always going to be a multiple. Well, 2 times the size. But unfortunately, all of these sort of failed. And you had to use the fact that O to b is parallel to O to n, i.e. there can't be any a part. So if O to n equals 2 minus 3 over 2 lambda a plus a half lambda b, and O to b is just equal to b, we get that 2 minus 3 over 2 lambda is equal to 0. That gives us a lambda equals 4 over 3, which gives us the O to n is hence 2 over 3b, i.e. n to b. N to b would be O to b minus O to n. So we get that this is a third b, And we're done. We've proved what we were trying to prove. Now for the last question. This one is particularly hard because for the first part we're going to use geometry, and we've got a very wordy question. So it's kind of a combination of two of the topics that people find most tricky at A-level. Now with that being said, note that a lot of these are show that, which means you can still attempt the following part even without doing part A. So for instance, part B is a lot easier than part A. You could do part B simply by using what you found in part A that they've stated. Likewise, part C, and so on. So you don't need to be able to do part A to be able to do part C. You don't need to be able to do part A or B to be able to do part C. So just bear that in mind with questions like this. So let's have a go. So a robotic arm, blah blah blah, uses draw a graphic design. That's our context. The arm is made from two rods OP and PQ. That's shown in the diagram, each of length D. This is quite sort of basic stuff you can see from the diagram. A pen is attached to the arm at Q. So our pen, which I'm going to just highlight in red, is at Q. The coordinates of the pen are controlled by adjusting the angle OPQ and the angle theta. For this particular design, the pen is made to move so that the two angles are always equal. So that means this here is also theta. I'm just going to put two red bits to show they're equal. Show that the x-coordinate of the pen can be modelled by this equation. So first of all, we're trying to find the x-coordinate. Considering we're given angles, we're given lengths, we're probably going to want to find other lengths. How can we talk about the x-coordinate in terms of a length? Well, it's a distance from the origin to that point along the x-axis. So we're trying to find this, where that dot's down. So let's have a go at drawing this diagram. So we've got our unknown part. We've then got the diagram. We've got this here is theta. We've got this here is theta. We've got this here is D. This here is D. And this really it continues on down to this bottom part. Like so. Now we're after this. Is there any right angle triangles that we can form so that we can find some lengths? Well, first of all, I see that these two could form a right angle triangle, these two sides. So to do that, I have to draw a right angle down like this. And if I just highlight this in, say, a white color, like so, we can easily find this white length. This white length is D cos theta. And I'll write that on the side here. Next, we have this. We want to remove this. Is there any right angle triangles that we can form with this length in? Well, actually there is. We can move it up like so. And then pulling down like this, we get ourselves a right angle triangle. Now by a Z angle, we get that this angle here must be theta. And well, because we know this length and we know an angle, we know that this length must be 2 cos 2 theta. So we get that our green length is equal to D cos theta minus D cos 2 theta. Now, this is the same as D cos theta minus. Now you might want to just guess what this comes to. In this scenario, you may not know many of these trig identities, but if we draw the graph of cos looks like this. Now, drawing on the same axis, sine looks like this. So it's almost like sine is the moved along version of cos. So in other words, we have sine of theta is equal to cos of theta minus pi on 2. And well, if you set theta to be equal to phi plus pi on 2, you can get some shifts. And what you can conclude is this is the same as pi on 2 minus 2 theta. Finally, we can bring in a negative because sine is an odd function. So you get d cos theta plus d sine of 2 theta minus pi on 2. Finally, we can bring out the d. And you can probably see now why this is so tricky. It requires a lot of knowledge about trig functions. My advice for you though, if you know this fact, the one we've used here where sine is odd, you can sort of guess this. You can guess this is what we're going to be after. And to be honest, maybe you might want to just write down this. Maybe try some angles just to check it works, just to check you haven't made a simple mistake earlier on. But yeah, really learn about your graphs, really learn about your transformations here. Really important. So that's the first part. Next, hence show that this is true. Well, what's the difference? We're talking about hence, so we're clearly going from x equals d times cos theta plus sine of 2 theta minus pi on 2. We're clearly going from that to this thing. So we want to try craft it into that, a bit like a clay modeler. So what's the difference? Well, the difference is I've only got cos thetas. So I need to convert all of these trig functions into cos thetas. So to do that, let's split up the sign. So if d times cos theta plus d times, well, it's going to be sine 2 theta cos minus pi on 2 plus sine of pi on minus pi on 2 cos of 2 theta. Now cos of pi on 2 is 0. So you get d cos theta plus d, this is going to be negative 1, and cos 2 theta. Now cos 2 theta, we need to turn that into cosis. So this is the same as 2 cos squared theta minus 1. Now at this point I kind of trust my maths here a little bit. I would now kind of assume that this is going to be exactly that. So this is equal to, well, yes, we have a single cos theta. We're going to have a positive 1 d, and we're going to have a negative 2 cos squared. So yes, that's going to be equal to d times 1 plus cos theta minus 2 cos squared theta. Now next, what they've done is they've completed the square on this all. Now when it says state the greatest possible value of this, what you want to look at, what changes. So d doesn't change, d is a constant. Theta is the only thing that changes. Theta is kind of locked up inside of here. So considering that this is a negative, it's subtracting, and I'm after the greatest possible value, I want to make this as small as possible. So what is this bounded upon? Well, it's bounded upon 0. This is a square number. Square numbers, the smallest they can be is 0. So this is strictly bigger than or equal to 9d over 8. Because that's what happens when this part here is 0. And well, that's 0 when cos theta is equal to a quarter. Or when cos theta minus a quarter equals 0. So that's the logic behind that part. Finally, part D. Figure 3 shows the arm when an x-coordinate is at its greatest possible value. Find, in terms of D, the exact distance O to Q. So we're trying to find this length here. Now we know that cos theta is a quarter. We're continuing on with that trend. Now, again, it's a geometry problem. What stuff do we know in geometry? Well, we have the sine rule, we have SOHCAHTOA, we have the cosine rule, we have the sine area rule. What are we given? We're not given a right angle triangle here. But we have 2 lengths. We're after another length, so that's 3 lengths in total. And we've got an angle. So this is the cosine rule. So if you saw 2 angles and 2 lengths, sine rule. 3 lengths and 1 angle all day long, that's our cosine rule. So we know that our length, which we're after, I'm going to call this y. Y squared is equal to, well, d squared plus d squared minus 2d cosine c, which is a quarter. So all in all, we get d squared, or 2d squared, minus a half d squared, which is equal to 3 over 2 d squared. So y, which is what we're after, our unknown, is hence going to be equal to the square root of this. So equal to the square root of 3 over 2 d squared, which we should simplify to be square root of 6 over 2 d squared. Oh, no square on the d. I hope that's okay. With geometry problems, try form right angle triangles, try to look for sine rule, try to look for cosine rule. That's pretty much all you're going to have to ever use in a geometry problem. Quite tricky. If you ever feel like you're missing something, go through and reread the question.